Welcome. Today we will see another problems of linearization of nonlinear functions. Therefore, up till now we have seen 4 to 5 problems. Now we will see next problems. Therefore, example 6. Determine the linear approximation for the equation z is equal to sin x cos y for xi is equal to 60 and yi is equal to 30. What is the approximate value of z when x is equal to 63 degree and y is equal to 28 degree? Therefore, we will find out this value of z approximate. Therefore, solution. This is our equation. Z is equal to sin x cos y. Therefore, what are they have given the values? Xi is equal to 60 degree, yi is equal to 30 degree, x is equal to 63 degree, y is equal to 28 degree. Therefore, the reference value zi is, therefore zi is equal to what? Sin of xi into cos of yi. Therefore, substituting the values of xi and yi, zi is equal to sin of 60 degree into cos of 30 degree. Therefore, zi is equal to 0.866 into 0.866. Therefore, zi is equal to 0.75. Now, we will find out the variation in small z. Variation small z due to variation in x and y. Therefore, first of all, we will find out values of small x and small y. Small x is equal to x minus xi, which is equal to 63 minus 60 degree, which is equal to 3 degree. Therefore, small x is equal to 3 degree into pi by 180. Therefore, x is equal to 0.0523. Similarly, value of small y we will find out. Small y is equal to capital Y minus yi, which is equal to 30 degree minus 20 degree, which is equal to 2 degree. Therefore, small y is equal to 2 into pi by 180. Therefore, small y is equal to 0.0348. These are the values of small x and small y. Next. Therefore, the variation small z is given by small z is equal to dou z by dou x at the point I into x plus dou z by dou y at the point I into y into small y. Therefore, substituting value of z in this equation, therefore dou by dou x of sin x cos y at the point I into small x plus dou by dou y of sin x cos y at the point I into small y. Therefore, we will differentiate this. By differentiation we are getting dou by dou x of sin x is nothing but cos x. Cos y will remain as it is at the point I into small x plus dou by dou y of now sin x will remain as it is. Now what is the differentiation of cos y? Cos y is equal to minus sin y at the point I into small y. Therefore, cos of xi into cos of yi into small x minus sin of xi into sin of yi into small y. Therefore, we will substitute the values of xi, yi and small x, small y. Therefore, we are getting cos of 60 degree into cos of 30 degree into 0.0523 minus sin of 60 degree into sin of 30 degree into 0.0348. Therefore, z is equal to 0.5 into 0.866 into 0.0523 minus 0.866 into 0.5 into 0.0348. Therefore, z we are getting it as small z is equal to 0.0226 minus 0.0150. Therefore, small z is we are getting it as small z is equal to 0.0076. Therefore, this is the value of small z. Now next, the approximate value of z is, that is Z approximate is equal to Zi plus small z. Therefore, we have calculated these two values earlier. Therefore, Zi is equal to, that is 0.75 plus small z is equal to 0.0076. Therefore, Z approximate we are getting it as 0.7576. That is Z approximate is equal to 0.7576. This is our example number 6. Now we will see next example. Example 7. Effect a linear approximation for y is equal to log x for xi is equal to 100. What is the approximate value of log of 101? Therefore, in this problem they have given one equation, that is y is equal to log x. They have given xi is equal to 100 and value of x is equal to 101. Therefore, solution, function they have given y is equal to log x, xi is equal to 100 and x is equal to 101. Therefore, we will find out first of all the value of yi, that is value of y at the reference point I. Therefore, before finding that value, we will find out value of small x. What is value of small x? Small x is equal to x minus xi, which is equal to 101 minus 100. Therefore, small x is equal to 1. Now, next, the variation small y is. What is variation small y? Small y is equal to dou y by dou x at the point I into small x. Therefore, small y is equal to dou by dou x of log of x at the point I into small x. Now, what is differentiation of log x? It is 1 upon x. Therefore, small y is equal to 1 upon xi, because this at the point I word point, that's why 1 upon xi into small x. Therefore, substituting the values 1 upon 100 into 1, because small x is equal to 1. Therefore, we are getting small y is equal to 0.01. Therefore, next, yi value we have not found out. Therefore, we will find out first of all, or we will find out yi is equal to, then we will find out at last y approximate. Therefore, yi is equal to log of xi. What is xi value? 100. Therefore, which is equal to log of 100. Log of 100 is equal to 2. Now, here we have to take log to the base 10. Log to the base 10. Therefore, log to the base 10 of 100 is equal to 2. Therefore, yi is equal to 2. Therefore, the approximate value is y approximate is equal to yi plus small y. Therefore, which is equal to 2 plus 0.01, which is equal to y approximate is equal to 2.01. Therefore, this is our approximate value of y for the function y is equal to log x. Now, we will see next example. Example 8. Effect the linear approximation for the function z is equal to x square log y for xi is equal to 5 and yi is equal to 100. What is the approximate value of z when x is equal to 5.1 and y is equal to 98? Therefore, they have given us the function, that is z is equal to x square log y. Z is a function of x and y, because here two variables are there, variable x and variable y. Therefore, solution, this function they are given, z is equal to x square log y, value of xi is equal to 5, value of yi is equal to 100, x is equal to 5.1, y is equal to 98, Therefore this variation small x and small y we will find out. Therefore first of all small x is equal to x minus xi, which is equal to 5.1 minus 5. Therefore small x is equal to 0.1. Similarly small y is equal to y minus yi, which is equal to 98 minus 100. Therefore small y is equal to minus 2. Therefore next, the reference value zi is, therefore zi is equal to, what is our equation, xi square into log of yi. Therefore substituting the values of xi and yi, we get zi is equal to 5 square into log of 100, which is equal to 5 square means 25 into log of 100, that is 2. Therefore zi we are getting it as 50. Now next, the variation small z is given by, small z is equal to dou z by dou x at the point I into small x plus dou z by dou y at the point I into small y, because z is a function of capital X and capital Y. That's why we have taken here z is equal to dou z by dou x at the point I into small x plus dou z by dou y at the point I into small y. Therefore next, therefore same equation I have written here, small z is equal to dou z by dou x at the point I into small x plus dou z by dou y at the point I into small y. Now we will substitute the value of z here in this equation. Therefore small z is equal to dou by dou x of x square log y at the point I into x plus dou y of x square log y at the point I into small y. Now first is differentiation with respect to x, y will remain constant, and second is differentiation with respect to y, x will remain constant. Therefore differentiation of x square is 2x, therefore 2x log of y at the point I into small x plus x square into, what is the differentiation of log y? Differentiation of log y is equal to 1 upon y. Therefore x square into 1 upon y at the point I into small y, which is equal to, therefore which is equal to 2xi into log of yi into small x plus xi square into 1 upon yi plus 1 upon yi into small y into small y. Therefore substituting values of xi, yi and small x and small y, we are getting small z is equal to 2 into 5 into log of 100 into 0.1 plus 5 square into 1 upon 100 into minus 2. Therefore z is equal to 10 into 2 into 0.1 plus 25 into 1 upon 100 into minus 2. Therefore z is equal to, we are getting it as 0.2 minus 0.5. Therefore z is equal to, we are getting it as minus 0.3. Therefore this is the value of small z. Now we will find out z approximate. Therefore the approximate value of z approximate is, z approximate is equal to zi plus z. Therefore what is the value of zi? Zi value and z value we will put here, that is substitute here. Therefore which is equal to 50 minus 0.3. Therefore z approximate is equal to 49.7. Now again we will see next example. Example 9. Effect a linear approximation for y is equal to x raised to 1 by 5 for xi is equal to 32. What is the approximate value of 30 raised to 1 by 5? How to read this? 30 raised to 1 by 5. Therefore solution, they have given us function y is equal to x raised to 1 by 5. Therefore they have given us data xi is equal to 32 and x is equal to 30. Therefore this small x, that is variation in x is equal to, small x is equal to x minus xi, which is equal to 30 minus 32, which is equal to x is equal to minus 2. Now the reference value yi is. Therefore, what is our equation? Y is equal to x raised to 1 by 5. Therefore, yi is equal to xi raised to 1 by 5. Therefore, substitute value of xi here. Therefore, which is equal to 32 raised to 1 by 5. Therefore, yi we are getting it as 2. Value of yi we are getting it as 2. Therefore, we have to find out now the variation in small y. The variation small y is equal to dou y by dou x at the point I into x. Now we will substitute value of y here and we will differentiate it partially by x. Therefore, small y is equal to dou by dou x of x raised to 1 by 5. This is the value of y at the point I into small x. Therefore, which is equal to, sorry, here 1 by 5 should be there. I think please take it as 1 by 5. Please consider it as 1 by 5. From my side, one mistake happened. Instead of 1 by 5, I have written 1 by 2. Therefore, sorry, 1 by 5 into xi raised to minus 4 by 5 into small x. Therefore, consider it as 1 by 5 into 32 raised to minus 0.8 into minus 2. Therefore, we are getting it as y is equal to minus 0.0625. Consider here 5 instead of 2. Therefore, the approximate value of y approximate is, therefore y approximate is equal to yi plus small y. Therefore, yi substitute value of yi and small y. Therefore, we are getting it as 2 minus 0.0625. Therefore, y approximate is equal to 1.9375. Now, next problem. Example 10. The volume V of a sphere is V is equal to 4 by 3 pi r cube. Determine the equation for the linear approximation for V. First, if Ri is equal to 10, what percentage error results from using this approximation for V when R is equal to 11? Second, what is the percentage error for R is equal to 9? Means we have to find out in this problem percentage error also. Means V approximate also will find out and we will find out percentage error also. Therefore, solution, they have given us this equation, that is V, that is volume V is equal to 4 by 3 pi r cube. Therefore, first of all we will find out value of small r, that is by using these values. Ri is equal to 10 they have given and r is equal to 11. First of all we will take this first point, r is equal to 10, r is equal to ri is equal to 10, r is equal to 11. Therefore, small r is equal to r minus ri, which is equal to 11 minus 10. Therefore, small r is equal to 1. Small r means variation in capital R. Variation in capital R. Therefore, now the reference value of volume Vi is, therefore Vi is equal to 4 by 3 pi into Ri cube. Therefore, substituting value of Ri is equal to 10. Therefore, 4 by 3 into pi into 10 cube. Therefore, Vi, that is reference value of volume at the point I, that is Vi is equal to 4186.66. Now, we will find out the variation in volume V is given by, therefore value small v is equal to dou V by dou R at the point I into small r, because what is the equation of volume? Volume is equal to 4 by 3 pi r cube. Therefore, only one term is there, that is capital R. That's why we have to differentiate that equation by dou R. Therefore, dou V by dou R at the point I into small r. Therefore, small v is equal to dou by dou R of, substitute value of V here, 4 by 3 pi r cube at the point I into small r. Therefore, 4 by 3 pi into, what is it? differentiation of r cube. Differentiation of r cube is 3r square at the point I into small r, which is equal to 3 and 3 will get cancelled. Therefore 4 pi ri square into small r. Therefore 4 pi into 10 square, substitute value of ri into small r, that is 1. Therefore small v we are getting it as 1256. Now the approximate volume V approximate is equal to Vi plus small v. Therefore substitute value of Vi and small v whatever we have obtained previously. Therefore which is equal to 4186.66 plus 1256. Therefore which is equal to V approximate is equal to 5442.66. This is the value of V approximate. Now next we will find out the error, that is when r is equal to 11. When r is equal to 11, v is equal to 4 by 3 pi r cube. Therefore substitute value of r is equal to 11 here. Therefore v is equal to 4 by 3 pi into 11 cube. Therefore v exact, that is this is the value of exact value, v exact is equal to 5572.45 at r is equal to 11. Therefore next we will find out percentage error. Percentage error is equal to v exact minus v approximate divided by v exact into 100, which is equal to 5572.45 minus 5442.66 divided by 5572.45 into 100. Therefore percentage error we are getting it as 2.32. Now they have told us to find out v exact at r is equal to 9 also. Therefore when r is equal to 9, this is again our equation, v is equal to 4 by 3 pi r cube. Therefore substitute value r is equal to 9 here. Therefore 4 by 3 pi into 9 cube. Therefore volume v is given by 3052.08. This is the exact volume. This is the exact volume. Therefore we will calculate percentage error. Percentage error is equal to v exact minus v approximate divided by v exact into 100, which is equal to, substitute the values, v exact is equal to 3502, this value we have take 0.08 minus v approximate from previously found out value we have to consider, that is 5442.66 divided by again v exact, that is 3502.08 into 100. Therefore we are getting it as percentage error is equal to minus 55.41%. Therefore this is the example of how to find out percentage error. Now next, example 11. The equation for area of parallelogram is shown in figure, that is equation of area of parallelogram is A is equal to WL sin theta. Determine the linear approximation for area A for WI is equal to 12, LI is equal to 8 and theta I is equal to 60 degree. What is the approximate value of A? Now here I will start when W is equal to 14, L is equal to 9 and theta is equal to 58 degree. Therefore this is our parallelogram. This is width, this is length. Width is denoted by letter W and this L is nothing but length of the side and this is the theta is nothing but included angle between two sides. Therefore here from this equation A is equal to WL sin theta, we are getting that area is a function of three variables, that is W, L and theta. Therefore next, solution. Here Wi is equal to, that is given data 12, Li is equal to 8, theta is equal to 60 degree, W is equal to 14, L is equal to 9 and theta is equal to 58 degree. Therefore we will find out variation in these values, that is small w is equal to w minus wi, which is equal to 14 minus 12, which is equal to 2. Similarly, we will find out change in L, that is small l. Small l is equal to L minus Li, which is equal to 9 minus 8. Therefore, small l is equal to 1. Similarly, we will find out change in angle theta, that is delta theta is equal to theta minus theta I, which is equal to 58 degree minus 60 degree, which is equal to 2 degree. Convert this into radian, that is 2 into pi by 180. Therefore, delta theta is equal to 0.0348. Therefore, these values we will use while finding out the variation in small area, that is small a. Therefore, here the function, which is a non-linear one, is given as a is equal to wl sin theta. Therefore, area of that parallelogram is a function of wl and theta, that is w is nothing but width, l is nothing but length, and theta is nothing but included angle. Therefore, the variation in area small a is given by small a is equal to dou a by dou w at the point I into small w plus dou a by dou l at the point I into small l plus dou a by dou theta at the point I into delta theta. Therefore, substitute value of a. What is the value of a? wl sin theta here. Therefore, small a is equal to dou by dou w of wl sin theta at the point I into small w plus dou by dou l of into bracket wl sin theta at the point I into small l plus dou by dou theta of wl sin theta into delta theta. Therefore, we will differentiate now this equation, that is wl sin theta, with respect to small w, with respect to l, and with respect to theta. Therefore, small a is equal to, we are getting as, in now differentiation of wl sin theta with respect to w. Therefore, what is differential, partial differential, we are getting l sin theta at the point I into small w plus differentiation of this value, that is wl sin theta with respect to l. Therefore, l is constant. Therefore, we are getting the equation w sin theta at the point I into l plus now differentiation of sin theta here. What is differentiation of sin theta? Cos theta. Plus, we are getting it as plus wl cos of theta at the point I into delta theta. Therefore, we are getting value it as, what we will do? We will obtain this equation in terms of ai. That's why we will divide this, or we will divide each value ai is equal to wl sin theta throughout. Therefore, small a is equal to, we are getting it as wl sin theta at the point I into small w upon capital W plus wl sin theta at the point I into small l divided by capital L plus wl sin theta into delta theta upon tan of theta I. Therefore, small a is equal to wl sin theta, we will take it common at the point I. Therefore, wl sin theta at the point I. Therefore, into bracket small w upon capital W plus small l upon capital L plus delta theta upon tan of theta I. Therefore, which is equal to small a is equal to ai, because this is the area of the parallelogram. ai into small w upon capital W plus small l upon capital L plus delta theta upon tan of theta I, equation 1. Therefore, we will substitute the values small w, small l, delta theta, w, l and theta I. Therefore, the reference value ai is, ai we have not calculated, ai is equal to wi li sin theta I. Therefore, what is wi? 12 into 8 into sine of 60 degree. Therefore, area at the reference point ai is equal to 83.13. Similarly, therefore, from equation 1, small a is equal to ai into bracket small w upon capital W plus small l upon capital L plus delta theta I upon tan of theta I. Therefore, substituting the values, we are getting small a is equal to 83.13 plus 2 divided into bracket 83.13 into into 2 divided by 14 plus 1 divided by 9 plus 0.0348 divided by tan of 60 degree. Therefore, by calculation, we are getting it as small a is equal to 83.13 into 0.1428 plus 0.1111 plus 0.02. Therefore, small a we are getting it as 83.13 into 0.2739. Therefore, small a is equal to 22.7769. We are getting this value. Now, the approximate value a approximate is, what is the equation? A approximate is equal to ai plus a. Therefore, substituting the values, ai is equal to 83.13 plus small a is nothing but 22.7769. Therefore, making addition of these two, we are getting a approximate is equal to 105.9069. 105.9069. Therefore, these are the problems on non-linear functions. We have seen 12 problems. Most of the problems I have taken from the book, that is unsolved problems are there. Therefore, all of you are requested to do the proper study, solve these problems on your own, try to understand, and if some problem is there, that is if you are not understanding, please tell me frankly. Thank you very much.